Hello everyone, welcome to the Fundamentals. My name is Ankit and today we will talk about class 7th NCERT acid, bases and salt. Okay, so after today's video you will be familiar with the terms like acid, base, salt, neutralization reaction, acidic nature, indicators, salt, base and what are neutral things, right? So let's start. So what are acids, what are bases and what are salt? So let's talk about them one by one. So before starting anything, I want to tell you some fundamental things so that it will be easy for you to grasp the definition and the properties. Okay, so the first thing is indicators. See, right, in your vehicle also you have left indicator, right indicator, that will give you direction. In the same way, suppose we have acids and we have bases. So there will be some indicator which will indicate us which one is acid and which one is base. So according to their property, they will change in their state, they will change in their color, or they will change in their smell. So by the change, we will get to know that which one is acid, which one is base, and so on, right? So as we are in the beginning, so we will talk about some basic indicator. So first one is litmus paper. So we have a paper, blue color paper and red color paper. So litmus paper is a common indicator available in red and blue forms. Red indicator, red litmus paper turns blue in the presence of bases, while blue litmus paper turns red in presence of acid. So now you will be confused, sir, which one is becoming what? So let me tell you again, acids are very dangerous and red is also dangerous. So if there is acid, the litmus paper should be red because both are, you have heard about the acids. Acids are very dangerous, right? So both are red. When there will be acid, it will turn litmus paper into red, and definitely we have two types of litmus paper, blue and red. So in this way you can easily get to know, like in your exam this question may come like red acid changes dash litmus paper to dash, like this. So you can write blue into red, and the vice versa, the bases can change red litmus paper into blue, right? So this is simple yet effective way to identify the nature of the substance, whether it is acid or base, right? So suppose we have a blue litmus paper. If you will put it inside the water, nothing will happen, it will get wet, that's it. And if you will put it inside the bases, nothing will happen, it will remain blue. But as you will put it inside the acid, or if you will put a drop of lemon on it, it will turn red. So in this way we can say water is, we don't know, but it is not acid. Bases, whatever base you will put, we don't know what is that, but definitely we are sure that it is not acid. But in the case of lemon drop, we can say it is definitely acid. In this way we can get to know about it. Same as bases. Second indicator is turmeric. Turmeric we are using at home also. It is a bright yellow spice, act as the natural indicator. When turmeric is added to the basic solution, it turns reddish brown. This color changes is due to the chemical reaction between the turmeric and the base, right? So when you will put base on the turmeric, it will become reddish brown. So this is the definition of base. If you will mix turmeric and the base, the turmeric will change its color, right? Okay. The basic example is, you can ask your mother that if you have some cloth, right, and you will put some haldi or turmeric on your cloth, right? Now it will become yellow. So as your mother will wash your clothes, right, so the yellow color will become reddish something, brown, reddish brown something, right? Why? Because the detergent what you are using at home is a base. So when they will react, when the turmeric or the yellow color and the base will react, it will become reddish brown. Okay, so the third one is obviously the Chinese things. We are surrounded by Chinese thing, right? Okay, So third one is China rose. This is the name. This is not imported from China, right? Okay, so the China rose petal. So let me show you what is China rose. China rose. So this is the China rose, right? You can get to know about it. The red color flower is the China rose, right? This is the photo. So China rose petals, when infused in water, create a natural pH indicator. In next slide, I will talk about the pH as well, right? pH. So China rose petals, when infused in water, create a natural pH indicator solution. Now what is pH? I will tell you in the next slide. This solution turns red in acidic solution, purple in neutral solution, and green in the basic solution. So you have to learn this, right? So it has different colors, right? So on substances like acid, bases and salt, it will show different properties, right? Okay. Now the second thing is, what is pH? Percentage of hydrogen. So it is a notation which will tell what is the percentage of hydrogen in any substance. So basically we will use this pH scale. It is a kind of scale, like you have your scale in the geometry box, right? So there are 15 line, 1 centimeter, 2 centimeter, 3 centimeter, like this. We have 15 line. In the pH scale, you have same, like pH scale is you can consider it in the same way. Okay, let me show you. So see, this is the pH scale, right? So you can see there are 15 numbers as well, from 0, 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14. So there are some different color for each and every number. It will tell us the percentage of hydrogen in any substance. So if a substance has the pH value less than 7, it will be called acidic. If the substance has a value, pH value greater than 7, it will be basic in nature. And if a substance has exactly 7 value, it will be neutral. So if a substance is having pH value 0, 1, 2, 3, these are very strong acids, and they may be very much harmful for us. And for 5, 6, it will be like weak acids, so we can use it for our daily purpose, for we can eat, or we can consume that, or we can use that. But the acids with the pH value of 0, 1, 2, 3, those are very harmful, and definitely we will use it for laboratory purpose, and for experiments, laboratory, and for industries and all. But we have to handle them with the care, right? But the pH values 5, 6, 7, they are easy, like lemon or something you can eat or consume also. In the same way, bases, the pH value of 8, 9, 10, definitely we can use it for soap, detergent and all. But the pH value 11, 12, 13, 14, so as the value will increase, the bases will become strong bases, and those are also very corrosive and harmful. So the pH scale, measuring acidity and basicity. So as I told you, if the pH range will be from 0 to 6, the nature of the substance will be acidic. Examples are lemon juice, vinegar, stomach acid. So stomach acid, we can call it gastric acid, or we can call it HCl, or we can call it hydrochloric acid. So these are the different name, right? So in our stomach we have HCl, so hydrochloric acid. So these all are acids, right? If the pH value is 7, definitely the nature of the substance will be neutral, like pure water. So it's a form of pure water where there is a minimum ions on it. So it is not neither acidic or nor basic in nature, right? Okay. Okay, let's come to the next slide. So let's talk about acid deeply. So how will you identify what are acids? So I told you, put a blue litmus paper on the acid, it will turn red, definitely it will be acid. Second thing, you have to taste it. But definitely, as I told you, strong acids we can't taste, right? it will burn our hand as well. If you will touch, it will burn, your hand will melt. This is that much dangerous. So everything you cannot eat or you cannot taste, but yeah, for weak acids you can taste. So they are sour in taste. Acid are known for their sour taste, which are easily recognizable in substance like lemon, vinegar, sour candies, khatta meetha type something. So if something is sour in taste, definitely it will be acid. Second, what I told you, if you cannot taste it because it is a strong acid, definitely we cannot then taste it, and then we will use a litmus paper. So we will take a litmus paper, we will put it inside the acid. If it will turn red, that means it is acidic in nature. As you can also see, the pH scale, the value 0, 1, 2, right? These are reddish in color. As it will come down, the color will change, right? So the indicator will show these colors. So on these basis, we can get to know about the exact pH value of any substance, right? Okay, now come back. Third, react with bases. Definitely when acid react with bases, so there comes the concept of neutralization reaction, what we will talk later, a little later. But right now, acid react with the base in process called neutralization. So if someone will ask you what is neutralization, you will say acid plus bases. When acid react with bases, this is neutralization reaction. So when they react, they will produce salt and water. So you can by heart it like this only: acid plus base. What? Acid plus base equal to salt plus water. This is the neutralization reaction. Now we will talk about the neutralization and the reaction later, but right now acid plus base equal to salt plus water. Okay. This reaction is essential for balancing pH value. Definitely to balancing pH values, a neutralization reaction is very much important. Stomach. So this reaction is very much important. And let's talk about some examples. Common examples of acids are HCl, which is very important, stomach acid, or we call it hydrochloric acid. Second is sulfuric acid. Formula is H2SO4. And we use H2SO4 or sulfuric acid in the car batteries. The citric acid, in citrus food we will get the citric acid, right, as a food preservative and all, in pickle, and for our daily purpose also we will use citric acid, right? Okay, so the citrus fruit like lemon, orange, grapefruit, lime, all contain citric acid, which give them the sour taste, right? Now the second thing is vinegar. Also you have heard about it. Vinegar is a dilute solution of acetic acid, which is used in cooking and cleaning purpose. It has a sharp, pungent smell and sour in taste. And the dairy product as well, like yogurt and the sour cream, contain lactic acid produced by fermentation of milk. The acid contributes to their tangy flavor and thick texture, right? Now let's talk about bases quickly. So by taste, these are bitter in taste. So bases are characterized by their bitter taste, which is often associated with the cleaning product and soaps, detergent, like this. Okay, but definitely you cannot taste the detergent and soap, yes, and the strong bases. So for that, what you will do, you will put a red litmus into the bases. So what will happen? It will turn the red litmus into blue. In this way, you will get to know that the solution what you are using is a base, and it has slippery feel. Like if you will touch the soap, how you will feel? Slippery, right? So many bases have slippery feel, which is noticeable in soap and detergent. This is caused by the reaction of the base with the oils and fats. So the bases or the soap and detergent have a ability to react with the oil and dirt. So as if you will mix water and if you will mix water and oil, what will happen? We cannot mix it, right? But that's why whatever oil, if you will if you have oil in your hand, go and wash your hand. So all the oil will be attracted by the soap, eh? And now if you will wash, so the soap can easily attract the oil, and then you can wash your hands, so your hands will be okay, right? So okay, so this slipperiness is caused by the reaction of bases with the oils. So base can easily react with the oil and it can attract it easily. This is the procedure how we wash our clothes, right? Okay. And at last, neutralization reaction, react with acids. Bases react with acid, definitely it is also called neutralization reaction, and it will also produce salt and water. I told you, right? Acid plus base equal to salt plus water. So now I am telling you base plus acid equal to, again you will say salt plus water, right? Okay. This reaction is essential for balancing pH level and pH value that I have discussed already. Okay. And reducing the acidity of alkalinity of the solution, right? Okay. So let's talk about some example. Soaps, detergent obviously. Okay, the soap are made up of fats and oil that have been reacted with the strong bases, typically sodium hydroxide, NaCl, or potassium hydroxide. This reaction creates a slippery substance that can clean dirt. Yes. So this is the procedure of how we wash the cloth. Second example is baking soda. So baking soda is also known as sodium bicarbonate. So you have learned it, okay? You have to learn it and you have to by heart it. It will help you definitely. Baking soda is also known as what? Sodium bicarbonate. Repeat with me. Baking soda is also known as sodium bicarbonate. Note it down. And is a common household base used for baking, cleaning and neutralizing acidic substances. Third is ammonia. The formula for ammonia is NH3. Okay, so it is a colorless gas with a pungent odor. Odor means smell again, right? So it has a pungent smell and colorless gas, and it is a strong base, and it's commonly used for cleaning agent and a fertilizer. And at last, detergent, I have already discussed. Detergent are synthetic cleaning agent that contain bases to break down the grease, dirt and the other stain. They are often used in laundry, detergent and dishwashing liquid, right? So now what are salt? I have told you, right? The bases has pH value from more than 7 and 14, right? 8, 9, 10, 11, 12, 13, 14. These are the pH value of bases. Now, if we will talk about the salt, so whenever I am talking about salt, it does not mean your kitchen's salt, right? Tata namak, desh ka namak. It is not like that. In science, we have different type of salt as well. So salt have pH value of 7, exactly 7. These are neutral component formed by the reaction of acid and bases. They are neither acidic nor basic, resulting in a balanced chemical composition. So let's talk about the ionic bonding of them. So how the ion will bond? So salt are formed through ionic bonds, where positively charged ion, that is cation, from the bases are negatively charged ion are known as anion. The ion from the acid and base attract each other, and they will create a stable compound. Now what is a stable compound? Stable compound ऐसा होता है, suppose if you will take some water, muddy water, right? Take some water, put some soil on it, now mix it. So what will happen? It will become brown in color. After some time, after if you give it like 10 minutes, 15 minutes, all the soil, all the dirt will settle down at the bottom and the water will become clean. So now this is the stable condition. Okay, so when all anion and all cation mixed together, they react. After the reaction, when everything is settled down, at that time it is known as stable compound, right? So the ionic bonding is something like, for one positive ion there is one negative ion, so equal number of positive ion or equal number of negative ion. In this way they will both mix, so they will make a stable compound, right? Okay. Now, as I told you, salt does not mean your household salt, Tata namak, Deska namak. It has a wide variety. There is a wide variety of salt, each with unique properties and application, from the table salt, that is NaCl, what we use at home, to Epsom salt, that is MgSO4, magnesium sulfide. They play essential role in various industries, from food processing to medicines. So if you will go to the medicine shop, right? So if you will read the information about the medicine, so they will say we have this salt. PCM, paracetamol, will contain this salt. So for a medicine purpose also, we will use different salt, right? So those are also salt. Okay, so some examples. So example of salt substance are table salt, what we use at home, NaCl, that is sodium chloride. It is the most common salt used for seasoning food or preserving meat. It is very essential for human health, regulating fluids balance and nerve function. That's why we use salt. Second one is baking soda. That's what I told you. Sodium, baking soda means sodium bicarbonate, right? So baking soda we can use for cooking food as well. Sometime we will use, right? Now Epsom salt, that is magnesium sulfate, MgSO4, is also known as Epsom salt, is used in bath salt and a laxative. Okay, so we have CaCl2, calcium chloride. It is a salt used for road de-icing. So what happened in the hill area or where the ice snowfall will happen too much, so there what will happen, so the road will also get blocked, right? So to clear the roads, what we will do, we will put some CaCl2, that is calcium chloride, there to de-icing the roads, so that road can be opened from the middle, so that vehicle can pass through. Okay, so we will use during winter we will use it on roads. It is useful for food production and as a drying agent as well, right? So calcium chloride is also a salt. Okay, at last, neutralization reaction, what I have promised with you, that I will tell you at last. We call it balancing the pH, right? So reaction process, I told you, neutralization occur when an acid react with the bases, resulting in the formation of salt and water. The hydrogen ion, that is H plus, from the acidic react with the hydroxide ion, that is OH minus. So H plus ion means acids, OH minus ion means bases. So when they will mix, they will form a water. The ion will form a water and the other thing will form the salt, right? Okay. The pH balance neutralization reaction are essential for balancing pH levels. When an acidic solution is neutralized by the base, the pH increases, moving towards the neutrality. Conversely, when the basic solution is neutralized by the acid, so its pH value will get decreased, right? So that definitely at last it will become 7. So when the pH value is 7, that means it is neutralized now, right? Now everyday application, neutralization reaction occur in many everyday processes. For example, antacids, neutralized stomach acid, like as I told you, right? In the case of acidity, ENO will work in 6 seconds. And the reaction of acidic soil with the lime helps to neutralize the soil's acidity. So in agriculture also we will use NPK, if you have learned about that, right? Balance the pH of the soils to get the good crop, right? Okay, so that's it about today. Thank you so much for being with me so far, and in the next video we will talk about the exercise from your book as well. Till then, goodbye.